Okay, good afternoon once again, and welcome to today's QT class. So today we are going to be getting started with portfolio variance. We have done quite a lot since the inception of the class in November. Today we are starting with portfolio variance. However, I think there's something I said I was going to provide more clarity on. Where's that question again? Uh, okay, I think this is a question. Question number 3 from the last class. So we had an issue with this second bit of the question, if you still remember. So let me just go over it again. As part of your work as a banking industry analyst, you build models for forecasting earnings per share of banks you cover. Today, you are studying Zenith Bank. The historical record shows that 55% of recent years, Zenith Bank's EPS has increased sequentially. And in 45% of recent years, the EPS has remained unchanged sequentially. At this point in your analysis, you are assuming that changes in sequential EPS are independent. EPS for 2009 were larger than EPS for 2008. What is the probability that EPS for 2010 will be larger than EPS for 2009? I think with that, you said it's a 55% chance from what the question gives us. Then the second question says, what is the probability that EPS decrease or remains unchanged in the next 2 years? And this is where we had the issue. Now, because of this or here. Now, let me explain that quickly. Okay, so probability, let me use this as a sample. People could either be married or what? Can anybody help me out? Married or what, please? Is it that somebody is married
Single.
or what?
Single now.
Great. Or single. I like the use of that word. Single. Now, this single here could mean two things. Do you agree with me? It could either mean that the person does not have a spouse at all, no spouse. The person has never been married. Okay? Or it could mean that the person is what? Um, a widow or a
Or
widower.
divorced.
Good one. That's even another option. Or divorced. Do you understand? So, probability of the other side of the probability of married can be stretched out into any of these three bits. Single, never married, um, widowed, or divorced. I hope you get the analogy. Now, the same
Yes, sir.
principle is what is applied here that we forgot, that I forgot in the last class. Now, we were told that the probability of success increasing sequentially is 55%. So if increase is 55%, first thing first, what is left? 45% is left. Now, what does this 45% represent? It represents either a decrease or a stagnation. Notice my use of or here. Both of them is combined. I hope this is clear. Can I get a feedback,
Sorry,
please?
not yet, sir. Can you recap? Can you explain?
Okay. So I go over it again. We were told that the
Yes, sir.
probability of an increase is 55%. So if increment takes 55%, what is left? We said 45% is left. Now, if 45% is left, what constitutes this 45%? If this is increase, what are the options left? It is either a decrease or a stagnation. Do we agree with that?
Yes.
Good. So in here, we have decrease or stagnation constituting this 45%. I think the Mr. talking now, I think you are the one who asked this question. You are the one who highlighted our attention to this question in the last class. So I need you to pay particular attention. So already, let me wipe this off so that we can get a bit more. already what we have here is a 55% for an increment. And then on the other hand, you have a 45% for either of two things. What are the either of the two things? A decrease or
Stagnation.
stagnation. So this is standing as one constituent part of the other probabilities. I hope it is clear now.
Yes, yes.
Now, let us address the question. The question now says, we are done with A. What is the probability that the EPS decreases or remained unchanged? This is one probability. This is one item. One. Albeit grouped together. In the next 2 years. So, for you to find the probability of something in the next 2 years, we need to get the probability of that thing in year one and the probability of that same thing in year two.
Year two.
So, what is the probability of a decrease or stagnation or remaining unchanged in year one? 0.45 or 45%. And then in year two, 0.45 or 45%. And means multiply. You multiply them together, you have your 0.2025. Is that clear now?
Yes, sir.
All right, so that explains that from last week. So we jump quickly to
Before you
what we
proceed, before you proceed,
okay.
Mr. Salako, sorry, sir, before you proceed, are we dealing with or, and? Because in the question it states or.
Ah, that means you are not following me. You are not following me in all I said. You are not following. So I'll take it one more time. Albeit the opportunity cost is the time, but we go again. First example, um, if you are not married, we said that the other alternatives are what? You are single. Now, this single could mean three different things. You could have been never married. You could have been divorced or widowed. 1, 2, 3. Never married or divorced or widowed. These three are the constituent parts of the single we talked about. So if the probability of marriage is 40%, the probability of single is what? 60. The probability of not married or divorced or widowed is 60. All these, even though they have all in between them, are already subsumed. Is that know if that's the right word? They're already included in this probability of being single here, which is 60%. Does that make sense, madam? Hello, madam. Does that make sense?
I'll watch the video again. Let's proceed.
Okay, so having said that, we were told that the probability of an increment is 55%. Then the probability of, if something is not increasing, there are two options. It's either it decreases or it remains
For
stagnant.
stagnance.
So if the probability, so look at it here, decreases or remains stagnant. So if the probability of increment is 55, what is left on the other hand? 45% is left on the other hand. Now, we are being asked in the question, define the probability that for the next 2 years, the EPS remains stagnant or decreases. So this is one single concept. It remains, probability of remaining stagnant or decreasing is 45%. That is the idea. So in the first year, 5%. In the second year, 45%. Multiply that together, you are having 0.2025. All right, so let's go over it at our leisure, and then I'm sure it will be clear. And if you have not watched all the previous videos up until now, you are not doing yourself a great deal of good. So please, you still have enough time. Let's go work on that. So today we want to start with a topic CIS loves to ask a lot, especially at the level 2. Okay, and then you see components of this in level 1 as well. So please, 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 I need you to pay attention. It's all about tactics, patterns. When you follow it, you should be good. So we want to look at portfolio variance. First, look at tell us what is meant by a portfolio. When you say portfolio, what does it mean?
Combination of securities.
Come again?
Like a combination of securities
A
held by an
combination of
individual
securities.
or
Beautiful. A
organization.
box, a basket, a group, a
Basket
bag,
of securities.
or whatever. Good. That's what it is. Now, we want to look at portfolio variance. And of course, you know that variance is what? The deviation of each individual component from its mean. We've done all that previously. We look at some of the examples. Now, the variance of return is a function of the variance of the component asset as well as the covariance between each of them. Variance, so when you're looking at portfolio variance, you're looking at the variance of the component assets as well as the covariance between two of them. Don't worry, we'll look at all these concepts in due course. In modern portfolio theory, a low or negative correlation between asset classes will reduce overall portfolio variance. The formula for portfolio variance in the simple case of a two-asset portfolio is given by, now, this is the formula we want to look at. When we have a two-asset portfolio, how do we find the portfolio variance? First, note that WA refers to the weight given to the assets. What weight did you give to Zenith Bank, which is your asset A? What weight did you give to GTB, which is your asset B? All right. Then you need to multiply the weight, the weight of the asset, the square, by its variance, the variance of asset A. Add it to the same thing done to B. Multiply the weight of A by the weight of B and multiply that by 2 as well. Then you multiply all that by the covariance between asset A and asset B. All right? And the whole information will be given here. The variance of asset A and asset B are variances, and this is the covariance between the two assets. Now, variance is a number greater than 0 because it is the sum of the square terms. If the variance is 0, there's no dispersion or risk. The outcome is certain and the quantity X is not random at all. Variance greater than 0 indicates dispersion of outcomes. Increasing variance indicates increasing dispersion, all else equal. Blah, 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 blah. Okay, so we have a question here. Data on both variance and covariance may be displayed in a covariance matrix. Assume the following covariance matrix for our two asset stocks. All right, so we have this covariance matrix here. From the matrix, we know that the variance on stocks is 350 and the covariance, the covariance of any asset to itself equals its variance. The variance of bonds is 150. The same principle apply. Bond to bond. The covariance of any asset to itself is equal to its variance. The variance on bonds is 150, and the covariance between stocks and bonds is 80. Covariance between stocks to bonds, 80. Stocks to bonds, 80. Covariance of bond to bond is the same thing as its variance, 150. Covariance of stock to stock is the same thing as its variance, 350. Now, I need you first to note this because you could find such questions like this in your objective questions, and this is how it might come. They could tell you bonds like this, and then this will not be there. This will not be there. They will tell you to find the covariance of bond to stock. You should know that the covariance of bond to stock is the same thing as the covariance of stock to bond. So when looking at the question, just pick the 80 here and put it in here, or you pick it in the options. Please note this very, very well. It's really important. That's the relationship. Now, the covariance, you could also be asked that what is the covariance? Or rather, they will tell you that this is the covariance matrix of bonds and stocks. So, what is the variance of the bond? Who can tell me what the variance of the bond is? Looking at this sentence, the covariance of any asset to itself is equal to its variance. So, what is the variance of the bond? Anybody?
Again, please. Again.
The covariance, this is a covariance matrix, okay? Bond to bond, bond to stock, stock to bond, and stock to stock. But we are being told that the covariance of any asset to itself is also known as its variance. Okay? So I'm asking that given this covariance matrix, what is the variance of the bond instrument here? Anybody? What is the variance of the bond instrument?
150.
150. What is the variance of the stocks?
350.
350. Please note that. Those are cheap objective questions. You could just you can just take in no time. Now we have this question sorted. All right, so let's go. How then do we go about calculating our portfolio variance? How then do we go about calculating our portfolio variance? Were we given... Okay, so that leads us back to this formula. What does the formula say? You need to know this formula. Okay, so you will not need to cram formulas, because at the in your answer booklet, you would have a series of formulas written for you at the back page. I want to believe that still remains the case. Okay, but whatever the case, by the time you practice this 2 times or 3 times, you should be able to write this on your own. It's really very easy to work with. So how do you go about this? Again, multiply the weight, the squared of the weight of A by the variance of A, plus the squared of the variance of B, the squared of the weight of B by the variance of B, plus 2 times both weights, weight A, weight B, times the covariance between A and B. All right? So now that we have that sorted, we have this information here. What is missing? The weight, probably. So we need to look into the question again. The variance of bond is 150, and the covariance between the stock and the bond is 80. Okay? Given our portfolio weight of 0.5, this ties back to what I was talking about last week. So if the weight of A is 0.5, what is the weight of B?
0.5.
0.5 as well. So given all that, I think all of the components we need to, slot into our formula is settled. So what do? We take them in that order. So we go. I want to find the portfolio variance now. So given this formula, I quickly just take the weight of A, 0.5, right, squared. Let me write it this way instead. 0.5 squared. I want to multiply that by the variance of asset A, which is what? Asset A. You can just tag them. Maybe you make your A probably the stock. Either way is fine. A or B, anyone that works for you, okay? A, B, or B, A. Anyone, you just know what you are working with. Are we good with that, please? So which one do we make A? Okay, let's just go by what we have here then. Let's make the first one A, and let's make this B. So we have 0.5 squared multiplied by, what's the variance of asset A, which is our bond? The variance is what? 150. All right, close your bracket, plus I move on to this second bit. The weight of B squared, 0.5 squared times, what is the variance of B? The variance of B here is 350, which is the covariance between the asset and itself. All right, then plus 2 times the weight of A times the weight of B. Then you want to multiply that by the covariance between both assets. And what's the covariance between both assets again? Who will tell me? Somebody help us out. What's the covariance between both assets? Hello, guys.
80.
80.
80. So now that we have this, we can now simplify a bit further. Can we just put up our calculators and give me an answer for this? Everyone, get your hands dirty. Type this into your calculator and tell me what you get.
$165, sir.
165 eventually. Please, you need to train yourself to be able to input all of these ones into your calculator and get an answer so as to save time. And there, here we have it. Okay. So what if our portfolio variance is given by 165? What was the relationship we established between variance and standard deviation in the last time? So if this is variance, how do you get your standard deviation? Somebody remind me.
Square root of variance.
The square root of your variance. Okay, so what is the square root? What is the standard deviation of this portfolio?
Square root of variance.
Good. So what does that give you eventually? You're getting a 12.85 when you find the square root. Are we good? So we move on to another. Okay, we have something else here to work with, which is a two-asset portfolio was used to illustrate this principle. Most portfolios contain far more than two assets, and the formula for variance becomes more complicated for multi-asset portfolio. Now, what if it had been a three-asset portfolio? How would we have expressed the portfolio variance? Let's have the formula written here. Flow along with me, guys. So we have three assets now, A, B, C. Our portfolio variance, will be, how do you do that? The weight squared of asset A multiplied by the variance of the same asset A plus the square of the weight of B multiplied by the variance of asset B plus the weight of what again now? The square of the weight of asset C multiplied by the variance of asset C. Then plus 2 multiplied by weight of A, weight of B, and weight of what? C. Are you with me? Then you want to multiply that by the covariance between asset A and asset B, covariance of asset A and asset C, and the covariance of asset B and asset C. So that's how we work that. If it goes to 4 assets, we expand further. All right, but I'm not sure you'll be asked any question beyond a 2-asset portfolio. So let's move on to this question we have here. Can I have somebody read for me from here, please? Anybody? Hello, guys. Can you hear me?
To illustrate this calculation, let's take an example where we have estimated year-over-year sales growth for 2 companies, Nigerian Breweries and Guinness, in 3 industry environments. Strong 30% probability, average 40%, and weak 30%. Our estimates are indicated in the following joint probability function. Nigerian Brewery sales 10%, Nigerian Brewery sales 4%, Nigerian Brewery sales 4%, Guinness sales 6%, Guinness sales 3%, Guinness sales -1%, strong 0.3, average 0.4, 0.3.
Okay, so our estimates. All right, so now, given a question like this, we need to calculate the covariance and then move on. We need to first find the weighted sales estimate. Again, probability is coming in here. I remember what I told you about probabilities the last time out. You simply multiply that probability by the given values you have. Now, what do we have in this case? We have Nigerian breweries and its sales at 3 different levels: 10%, 4%, -4%. We have Guinness, 6%, 3%, and -1%. And we have the probabilities at each of those levels. Okay? The covariance between them all in those instances. So what do we do? I need you to pay particular attention here. So you go for Nigerian breweries, you take each value here and multiply it by its corresponding probabilities. Then for Guinness, you take each value here and multiply by its corresponding probabilities too. That's how you find the weighted sales estimate for each of them. All right, so we go. NB, that will be what? 0.3 times 10% plus 0.4 this here times this 4% here plus 0.3 times -4%. Can somebody please help me out with this? What does this give you up as a final answer? I go for Guinness, 0.3 times 6%, 0.4 times 3%, 0.3 times -1%. I hope you are punching our calculators right now. So tell me, what are we getting here?
0.034.
0.034. Expressed as a percentage, 1 to 3.4%. All right. Can we do the same thing here too?
That's GUI.
Guinness from here.
0.027.
0.027, and this gives us eventually 2.7 as a percentage. Now, these are our estimates. So, what do we need to do? We need to create a table now. Let me do that here. All right. So please just follow along with me. Okay. I have three probabilities. Remember, we've got strong, average, and weak. So what do I do here? Strong. I want to draft up my table now. Average, weak. Now, asset A, or better called Nigerian breweries. I need to find the deviation. What is the deviation? I take away its mean, which you just got now, the average estimate now. Okay. I take it away from each individual component therein. 10% minus this, 4% minus this, -4% minus this for A. Then I come back and do the same thing on this second column here for my asset B. What's my asset? What is its deviation? I do the same thing across board for them. So let's do that first and foremost. So we go. We have all these values here. So this will be what? 10 minus 3.4,
6.6.
6.6.
6.6.
The second one there is 4. 4 minus 3.4. I didn't hear you.
0.6.
0.6.
0.6.
And then the third one is -4. -4 minus 3.4.
-7.4.
-7.4. Beautiful. So we move to that of Guinness. 6 now minus 2.7. 6, 3, -1. 6 minus 2.7.
3.3.
3.3. 3 minus 2.7.
0.3.
And the other one is -1 minus 2.7.
-3.7.
-3.7. Now that we have this, we move on to find the cross product. Cross product of deviations. So what is a cross product? Simply multiply both values you have gotten, A by B. So we go, give it to me, 6.6 times 3.3.
21.78.
21.7 what?
8.
Okay, this should be 0.18 or yeah.
1.8.
And this will become a positive what?
27.38.
27.38. Now we have the cross product. Okay, so we bring back the probability that we were given initially in the question. What was the probabilities? 3, 4, 3. Over here, probabilities. Okay, so what do you want to do with the probabilities? Just list them accordingly. And then you want to multiply. Let's tag this column C and tag this column D. You want to get the weighted probability here by simply, let's tag this column E, by simply multiplying your C by D. This is your weighted probability. Okay? So let's go again. 21.78 multiplied by 0.3.
6.534.
6,534. This will give you what?
0.07.
And this is help me out.
8.214.
8.214. It's only when you have gotten this that we need to sum up here and we arrive at our covariance. So please sum this up for me.
Fourteen point eight two.
14.82.
14.82. 14.82. So these are the processes we took all the way down, and then you get your 14.82 here. Okay, so just take your time, go over it, and you should be fine. Now, there's another concept here that we need to look at, and it's called Bayes formula. All right, Bayes formula. Can I have somebody read for us, please? From here.
Bayes formula shows how to calculate an updated probability. The new probability given new information. Bayes formula is the updated probability of an event given new information. For an analyst, learning from experience takes the form of adjusting expectations and probability estimates based on new information. Bayes theorem. Let A1, A2, all the way to AN be a set of mutually exclusive events that together form the sample space S. Let B any event from the sample space, from the same sample space, such that probability of B is greater than 0. Then probability of A subscript K divided by B equals probability of K.
All right, let me take it up from there to avoid confusion. All right, so let me put it this way. Probability of A and probability of A prime, or A subscript, A prime. What does this mean? Can anybody tell us what you should understand by these two? What does this mean? Can I get any ideas? Any idea? If the probability of A is 67%, what does A prime? What's the probability of an A prime?
33.
That will be 33%.
Good. So what does A prime mean? Simply not A. Is that fine by us? Not this one. Okay? 33%. So this formula, when it comes to Bayes theorem, permits me to rewrite it this way. That and of course, you know what this means. We've done this before in our conditional probability and total probability. What's the probability of A or the complement of A when B is a condition that has already been given. I hope you say remember that, please. Hello, can I get a feedback from you guys?
Yes.
Okay, so condition has been given already. That's what the condition here means, the B. So I want to rewrite this question to avoid confusion. So I could say the probability of A prime when B has been given is the probability of that A prime multiplied by the probability of B when A prime has also been given. Okay, just look at it. You see that it's like I'm just changing AK for A prime here. All right, then divided by probability of A prime multiplied by the probability of B constant, B given, A prime, A is your condition, plus the probability hold on. Am I mixing this up? Okay. I think I've mixed this up. So let me do it this way for clarity purposes. All right, let me do it this way for clarity purposes. I want to go with, please don't mind the letters though, don't be confused. You know I said A and A prime, right? So let me express it as A1 and A2, still meaning the same thing. Are you with me, please, or we are confused? Can I
Okay,
hear
sir.
from you guys, please?
Yeah.
I can't hear
Yes.
you. Please speak up.
Yes, sir.
We are together. Good. So it's the same concept still, oh, but I don't want to use A and A prime. Let me just go with A1 and A2. The same concept applies. So what is the probability of A1 when B is given? So that will be probability of A multiplied by the probability of B when A is a constant divided by probability of A multiplied by the probability of B when it's a constant plus probability of A prime now, or A2, the other bit, multiplied by the probability of B when A prime or the other bit A2 is given. That is what this formula is trying to express here. All right, so let's go over all of this again. We already know that when you have probability written as this, probability of Y, K, it means that something is a constant or a conditional that has to be given for this to come into play. All right, so we have our A1, A2. You know what it means. If this is 60, A2 is 40, as they must always sum up to be 1, the other part of each order. So what's the probability of A1 coming up, given that B is a condition that A1 relies upon? So that is expressed as the probability of A multiplied by the probability of B, given the condition of A1, all divided by the probability of A1 times probability of B, given A1, plus probability of A2 times probability of B, given A1. Now, let's leave all these variables and try to put in a question and see if it will make more sense to us. In fact, I like how this question is placed. So you can just see the formula and work along with it as well. Okay. All right, so let's have somebody read the question Okay, please read the question for us. Let's go. Example 6. Who is helping us out? Hello, guys. Please help us with the question. Example number 6.
A company is due to release the third quarter results tomorrow on the floor of the Nigerian Stock Exchange. In the last 10 years, the company has paid interim dividends only 5 times after the release of its quarterly results. An analyst has predicted that the company will pay a 1 naira dividend after the release of the results. The analyst is well respected in the market because he is always right 90% of the time. His record shows that he incorrectly forecasts a company's corporate action only 10% of the time. What is the probability that the company will pay the 1 naira dividends forecasted by the analyst?
Beautiful. Okay, go on.
The sample space is defined by 2 mutually exclusive events. The company pays 1 naira dividend or does not pay. Additionally, a third event occurs when the analyst forecasts the company's corporate action. Notation for this event appears below.
All right, so let's interpret this question now based on what we have seen here. What are the 2 mutually exclusive events? The company pays 1 naira dividend or it does not pay. So it pays. Let's tag that as our A1. All right, company pays dividend. So what will our A2 be? Anybody?
Does not pay.
Company does not pay. Company doesn't pay. Please, you get it now. Just follow along with me. All right. Now, an analyst is doing something. What is the third factor in here? The analyst forecasts the company's corporate action. Now, let's go into the question. An analyst has predicted that the company will pay 1 naira dividend after the release of the results. The analyst is well respected in the market because he is always right. What percentage of the time?
90.
90%. So what does that mean? It means that our B, or let me put it this way, the probability that given we know the company will pay dividends, but the probability that this guy is right is what we want to look at now. Right on what? The condition that the company will pay dividend is 90%. Now, what does this mean? It means that the probability that this guy fails, or the probability of this guy's prediction, the company will not pay, will therefore equal to what? 10%. Do you understand these notations, please? Before I move on.
Again.
I didn't hear you.
Again.
All right. So a company is due to release its third quarter results tomorrow on the floor of the NGX. In the last 10 years, the company has paid dividend only 5 times after the release of the quarterly result. Analysts has predicted that the company will pay 1 naira dividend after the release of the result. Its prediction is that the company will pay 1 naira dividend after the release of the result. The analyst is well respected in the market because he's always right 90% of the time. So how did we interpret this? The probability that the analyst is predicting right that the company will pay the dividend is what? 90%. The probability that the analyst is predicting wrongly now that they will pay, or rather that they will not pay, is now 10%. Does that clarify it for you, please, before we move on?
Yes.
Now that this is settled, now let's now go into the upper part of this question, because there are some things we need to clarify here. We already have said that probability of payment is denoted by A1. So what is the probability of A1 actually the company pays? Look at what we were told here. A company is due to release its, what is this? Third quarter results, blah, blah, blah. In the last 10 years, the company has paid 5 times. What does this tell you? It tells us that dividends are paid on a quarterly basis. A company is due to release its third quarter results tomorrow on the floor of the Nigerian exchange. In the last 10 years, the company has paid interim dividends only 5 times after the release of the quarterly results. So there's a bit of calculations we need to do here. So what is the probability of the company paying dividends? They paid 5 times, right? In how many years? Help me, somebody. In how many years?
10 years.
10 years. But remember that they have been paying the dividends after the release of the quarterly results. So what does that mean? In every 1 year, there are 4 quarters. So ultimately, the probability of paying dividends is 5 times out of what? 40 times. I don't know if that is clear to us all, which is the same thing as 1/8. Expressed as a decimal, this should give you 0.125. Please, who does not understand what I've just done here? I need to know. Who does not understand what I've just done here?
So can we call this like periodic payments?
Definitely. However, the periods are what? Quarterly. The question could have been half yearly or semi-annually. Should have been multiplied by 2. Okay? It could have been monthly. It should have been multiplied by 12. I'm sure by now you are very familiar with that. So can we continue?
Yes, please.
Okay, so now that this is clear, what then is the probability of the company doesn't pay, which is A2, the company doesn't pay? We can choose to go over, I think the best thing to do at this point is just to say 1 minus the probability of payment. Let me approximate that to be 0. What would this give us? 875, right?
Yes.
Sorry, it should be, I
The
jumped.
answer would be 0.
Yeah. 1 minus 0.1. I really need to calm down. 125, and here we end up with 0.875. Please, is this clear to us all?
Sir.
Did you say yes, or you want to ask a question?
It's not clear, sir.
Okay, so which portion? From where exactly? I'm sure you understood up until here. Did you get up until here?
Yes, I understood. Yes, I stopped there. Like the 10% is the percentage when they did not pay dividend.
Yes, that the analyst did not predict that.
Yes.
You understood up until here. Could here
Yes,
be
sir.
the problem?
Yes, sir.
Okay, so If I tell you that I'll pay you 10 naira every year, how much should you get after 5 years?
That will
Talk to
be
me, talk to me.
10 naira, and that will be 50 naira.
50. What did you do? You simply multiply that 10 by 5, right?
Yes, sir.
Now, what if I tell you that I'll be paying you 10 naira for 5 years, but this time I'll be paying you that 10 naira 2 times every year? That means in 6 months, you get 10 naira. In another 6 months, you get 10 naira. How much will you get at the end of 5 years? Are you still there?
Yes, I am. Like the 10 naira, you'll be paying me after 2 years.
No. I will pay you 10 naira in 6 months. How
Okay, in
much
6.
will you get in 5 years? So
Okay,
you
that will
start.
be
Okay, go
on.
on.
That will be twice in a year for 5 years, right?
Yes.
Okay, that will be
100 naira.
10 on 100,
How did
50
you get to
plus.
100? Break it down for me.
And since it's 10 naira, that will be 20 naira in 2 years. And in 1 year, since you are paying me 10 naira in a
Good
year, right?
one. Mm-hmm.
In 6 months. So the 10 multiplied by 2, that is 20. Then the
Mm-hmm.
20 multiplied by the
5
5,
years.
5 years, that will be 100.
Beautiful. Beautiful. Now that you have that basic sorted out, let me wipe this place off. Okay. And then let's go back in here. So look at the question. In the last 10 years, the company had paid interim dividend 5 times in the last 10 years. Ideally, we should have 5/10. That is, we should have been the ideal thing. Thinking that it is one time in a year that they pay. Are you getting me now? Are you still there?
Yeah, I'm here, sir.
Good. However, we are told that the dividends are paid 4 times every year. So these 10 years,
5
every
times,
1
not
year
4 times.
is 4 times. So 10 years has to be 10 times 4. Does that make sense to you?
Yes, sir.
Good. Because it is probability, it now becomes the number of time they paid times the total periods they ought to have paid. 5/40. That's how we got this one here. So up until here, it is also clear now, right?
Yes, sir. Thank you.
Good. Is this clear, therefore? Is this second part clear too?
The second part. No,
This
not
part.
really, sir.
So let me explain that. If I told you that in a class, we have 10 students and 7 of them are boys, how many girls are there?
3.
How did you get the 3?
The 10 minus 7. The
10
remainder,
minus
since
7.
7.
Good.
Yes.
Good one. So probability is all about a whole, one whole orange. So if the probability of something is this bit, the probability of the other part will be the whole minus that bit. The whole is often referred to as 1. So if the probability of paying dividends is 0.125, probability of not paying dividends will simply be 1 minus 0.125. Are you still following?
Yes,
And that
sir.
gives us this value here. I hope I've clarified that bit now.
Yes, sir. Thank you, sir.
So now that we are on the same page, everybody, let's just input all these values we have into this formula we were able to rewrite or rephrase earlier, and we should be good to go. So the question is asking us, what is the probability? Or let me read it again so that we just come up to speed. A company is due to release its third quarter results tomorrow on the floor of the NGX. In the last 10 years, the company had paid interim dividends of only 5 times after the release of its quarterly results. Analysts has predicted that the company will pay a 1 naira dividend after the release of the results. The analyst is well respected in the market because he is always right 90% of the time. That means 10% is wrong. His records show that it incorrectly forecasts a company's corporate actions only 10% of the time. What is the probability that the company will pay the 1 naira dividend forecasted by the analyst? This is the conditional bit. So how do we express that? Probability of payment of 1 naira dividend given that the analyst has forecasted it. Are we still together?
Answer,
So
please, sir. Say that again.
probability that the company will pay dividend given that the analyst has forecasted it. And this does what? Ties in into what we have in here. So given such a question, you just pick up all that you have been able to deduce here and put them in accordingly. All right? So, let's go. What is the probability that the company will pay dividends? Are you still there?
Yes, sir.
0.125. I want to multiply that the probability that the analyst predicted that the company will pay dividend. What is that? Give it to me.
90%.
90%. Permit me to express that as 0.9. Then divide that by probability of paying dividends, 0.125, multiplied by probability of the analyst has predicted that they will pay, 0.9, then plus probability of paying dividends, 0.875, multiplied by the other side of the analyst prediction, 0.1. Input this into your calculator. What do we get?
That would be 0.5625.
56.
25.
5625. All right. So that is that about that. Let's check here. All of that is what we have done. Okay, we have 0.57 here. Okay, and this is just due to estimation, approximation errors. All right, so why we used 0.125? The book they use 0.13, so is minimal, and I think we are good to go. All right, so I want that we call it a day here. Please go over all we have said, all we have done, and then we'll continue from there in the next class. All right,
Thank
so
you.
that's that about that, guys. See you in the next class.
Thank you, sir.
Thank you. Thank you, everyone.
Yes, sir.